Okay, so I believe most of you have either heard of or used Alexa or Siri. The presence of these speech assistants have made our lives much more convenient. A lot of computer scientists are actively researching on relevant topics, so today our topic is going to be how to make computers better conversationalists. First of all, what is speech processing? It's a discipline in CS that deals with designing computer systems that recognizes spoken words. There are two subfields for that. The first of all is automatic speech recognition, where the input is a speech and the output is a text. So some of the application includes the Google services and also Siri and Alexa. So it's comprised of two models. The first model is the acoustic model, where the input is speech and we output a phoneme, which is a phonetic representation of the speech. And the second part is the language model, where the input is a phoneme and the output is actual text based on the grammar and context. It uses a lot of linguistics, natural language processing, neural network, etc. The second subpart is called speech synthesis, which is actually the opposite process of the previous part. Here the input is a text and the output is speech. So the application, also Google has a speech-to-text service, and also a lot of the famous songs today are sang by computers. Similarly, it's a two model part. The first part being the input is a text and we output the phoneme, and the second part we're taking the phoneme and output speech. There are also other subfields such as voice conversion, multilingual speech processing, etc. So why is that important? Well, first of all, we all prefer speaking to typing, which saves us a lot of time. So it makes our conversation with computers more efficient. And second of all, many people have problem reading or typing due to various reasons, so it may be helpful for those people. And also, it might be very useful if you're learning a new language. For example, the language learning app Duolingo have that feature. And also, the company that I work for this summer, Carnegie Speech, are developing a speech grader for TOEFL and IELTS tests. So you can see from this graph how speech processing is linked with many CS subfields, and also it has a very broad application. Okay, so what are some of the research directions for speech processing? Well, first of all, it was always better to have more accurate speech recognizers. So a good goal was to reduce word error rate. Currently, a good speech recognizer can do that about 10% word error rate, but we can certainly do much better. And second, what to do with different words with similar pronunciations. That's actually a big issue in many of the languages, including English. And also, some of the languages we don't have much data on, so it might be very hard to build a machine learning based model, and so on. So there are actually a lot of researchers in CMU working on this part. The most famous one being Professor Alan Black and his team. So they did a lot of researches in the past few years. First of all is the mixed language navigation instructions. So this is a text-to-speech project that's designed to help taxi drivers in multilingual countries such as India. So the principle is that when these drivers give instructions, the language might be in English, but the place names might be in native language such as Hindi. So the project kind of needs two different models for two separate languages. And the second example research is segment level voice conversion with recurrent neural networks. So in this case, we're dealing with the difficulty that the source and target speakers speak at different rate, and they have different utterance length. So this can be a huge problem in terms of speech conversion. So this project proposes a new techniques in dealing with that problem. Okay, so now we're going to take a more deeper look in the current research in the field.
Okay, so now we are going to talk about current research in the field, particularly here at CMU. So let's say that we have that we want to make an ASR for the Turkish language. However, the only data we have comes from a particular use, and we want our ASR to work for a variety of domains, like everyday conversations. So this was the topic of research that was conducted last July by two graduates at the Language Technology Institute, Siddharth Dalmia and Jijan Lee, and two professors, Florian Mitze and Alan Black. So their idea is that we have already ASRs that work well for the English language for a variety of domains, and perhaps we will be able to, by looking inside of these ASRs, to extract features that are domain invariant, in the sense that they return the same value when they are applied to a particular word, regardless of whether this word was spoken in one domain or in another. So these features, we may be able to export them into our Turkish ASR to make it more robust to other domains. So for their English ASR, they used the Aspire model, and they did a lot of experiments to find which parameters are domain robust, and they discovered that the parameters from the third layer of their TDNN are domain robust. So they used these for their ASR for the Turkish language, and the error improved by 15% over the baseline. So one good feature of this technique is its efficiency. It is very fast to develop. So training on the Turkish data is going to take little time because we have small data from the Turkish language, and extracting the features from the English ASR is also going to be pretty fast because the ASR was already trained by past teams. We are only going to extract the features from it. Now, before we are going to get to the second research paper. It talks about how to use context to achieve end-to-end speech recognition. So before we talk about it, let's talk about what is end-to-end speech recognition. So recall that an ASR has two parts, the acoustic model and the language model. So the acoustic model has the responsibility of converting the sound waves into their phonetic representations, and the language model is responsible for converting the phonetic representations to their characters. So the first part is more or less mechanical. We can expect the computer to perform well on it. The second part, on the other hand, is unintuitive and tricky. It's hard to expect a computer to be able to guess that kernel is supposed to be written as C-O-L-O-N-E-L. So instead, what we do is that we refer to pronunciation lexicons. These are made by human experts. They list a lot of words and they write their phonetic representations. There are problems with these. First of all, they don't exist for many languages. Second of all, even for languages where they are well developed, like English, we keep getting new words, and so we need to keep hiring these people, and this is expensive and pretty labor-intensive. So the idea of end-to-end speech processing is that we take the sound waves, and the ASR is going to automatically convert them into characters without using human expertise. So the idea of the research paper that we mentioned is to use context to achieve this end-to-end speech recognition. So as they are decoding the utterances, each utterance that they decode into a word, they will take this word and save it in a context vector. And then when they get an utterance and they are going to decode it, they look at all of the context vector that was developed thus far and at the utterance to predict which word this utterance represents. So let's get into the future directions that the research in speech recognition seems to be heading toward. On the cross-lingual track, there's the question of whether we can train ASRs on more than one language. So the research I showed used one model. There was one model that was trained on the English language, and they trained a model on the Turkish language, and they used some features from the English ASR. The question is, can we use data from a lot of languages to feed it into an ASR that will be able to use all of these and perform well on all of these languages? And if so, how? And a second question on the end-to-end track is, what are better ways of representing the context vector? Because not all words that have been said so far are representative of the context. A third question is how to deal with inaccurate pronunciations. So some people speak in their second languages, some people have accents, some people have dialects. So how do we make our ASRs more robust to these? So that was pretty much for today. Thank you very much.